So today the topic that we are going to discuss is called NLP, right? Now, before starting with the discussion and the other concepts in NLP, I would like to ask that how you can understand NLP in real-time scenario, or you can say any application you know about where you see NLP is working in real time. Anyone?
I think it's when we're looking at examples like ChatGPT, Gemini, and any
Mhm,
other AI-powered service or something of the
mhm,
sort.
mhm. Correct, correct, correct. Okay, so see, what is NLP? NLP stands for natural language processing, right? Understand what this processing or language, why we are processing language, first of all, understand. Let's assume like this, you are interacting with an AI assistant, right? Let's suppose Siri, and you give some instruction. So how Siri is understanding that, right? How the machine is understanding your words, how it is identifying the meanings, understanding the hidden information from those words, right? That all we discuss, the methods that we use, that all we discuss in this NLP part. Getting my point?
Is it when we're speaking about input text processing,
Correct,
vectorization,
correct,
prediction, and all that? Yeah.
correct, right. Okay, so NLP consists of lot of concepts, right? And if I talk about the application of NLP, so the few very famous applications like sentiment analysis, right? Text analysis, speech to text, text to speech, right? These are some very famous application of NLP, right? Where you can see uh, how NLP works in real time scenarios. Getting? Now, let's have a quick, just a second. Let's have a quick look at the one PDF that I have created. Where it is. So here, it's a kind of a summary sort of NLP, right? So what NLP is basically, it's a kind of a bridging human and machine communications, right? Uh, so it's basically comes under the AI. Okay, so if you want to go in NLP, first you have the understanding of the ML, right? Because ML is the first step moving towards the AI. So we are focusing here on enabling computer to understand, interpret, and generate human language, right? Just like if you give any instruction to the chat GPT or Siri, right? Siri gives this output in the same way. That is in a human form. Here, an estimated of around 15 million billion pound in 2023 is projected to reach around 130 billion by 2032, highlighting its pervasive influence, right? Means the influence it is making on entire or in every sector, right? Or in real life as well. Now, then, this is a kind of a evaluation of NLP. So it starts from early 50s and 70s, where we have rule-based systems, right? So these rule-based system basically uh, they defined or they are following some rules to generate or to create the output, right? Then in 80s and 90s, the statistical method developed. So here, basically, statistical means we are using the probability to generate the output. And types of model we have used here, like ngram. So what is the ngram? We will talk about it. And there is then Markov model. So Markov model is a Markov chain is basically you will study in your physics as well, right? The same thing we tried to apply in the AI part under the NLP section. Okay, and we created some Markov models, like part of a speech, POS tagging. So what is this POS tagging? We will see one example on it. So here some examples are given, like in 1966, a pioneering chatbot simulated conversation by using simple pattern matching and substituting rules. Then here in a statistical method, as these methods are relying on probability, right? So there definitely some sort of you can say challenges always are there. Kind of if you don't have relevant data, if you're not having sufficient data, it's it will be difficult to generate a accurate output, right? So that was the basic challenge while working with the statistical methods. Then we have rise in the machine learning and deep learning. Okay, so from the 2000s and till now, what are the you can say changes happen. So earlier we have called the machine learning era, in which we have algorithm, SVM, random fields, right? So these are the most frequently used you can say algorithm or methods at that time was. How many of you understand support vector machines? Anyone?
Again, I didn't get the question.
uh, what are support vector machines? Any idea? Any one of you?
No.
Okay, see, support vector machines are quite, you can say, quite useful while classifying the data. Okay, so what they do on the basis of some threshold that we call as support vectors, right? So these are nothing. These are simply some numerical values on the basis of which they classify the data, right? They make a category of the data that we call as basically support vector machines. So initially, these are quite famous, support vector machines and other, right? Then in 13, another approach called word embedding. Word embedding, basically what we are trying to do, we are trying to convert word to the vector. So word to vec means word to vector. Now, what are vectors? Vector are mathematical entity in which you have a, you can say, in which you have a magnitude as well as a direction, right? So what we are trying to do here, words are converted into a form of vector which you can represent in a 2D plane, that is a two-dimensional plane, that are called as vectors. Then in 15, just a second. Uh, wait. Mm, right. So that is what word to vec means, right? That is representing your words in the form of a vector. Okay. Then coming to RNN and LSTM. If anyone of you have attended the previous sessions, so we have discussed a lot about RNN part. Anyone in the session right now? Okay, what is RNN? If anyone know? Okay, what is ANN? Artificial neural network. No one.
ANN is artificial neural network. I think is how the computers mimic the brains, the action of the brain, like the neurons in the brain, how the computer tries to act as a human brain by mimicking the actions of the brain. I think that's ANN. In ANN. Sorry, can you get me?
Yes, yes, yes.
You were asking the question about ANN.
Yeah.
So I was trying to explain what I think ANN. I don't know if you got me.
Your point. Got your point.
Okay, thank you.
Got your point. Right. So simply, what is ANN? ANN or artificial neural network is a network which tries to, you can say, process the information just like a human brain do. Okay, in the same way. There are three types of neural network, which is called ANN, CNN, and RNN. ANN and CNN both are having, you can say, having a difference between R and N is that R and N having a, or you can say, having a memory, that is a hidden layer which acts as a memory so that it understands or it remembers the previous inputs, right? That is one of the major difference between the ANN, CNN, RNN. And there was some shortcoming of RNN. To overcome of those shortcomings, we developed LSTM, that is short term memory, right? It's again uh, part of the RNN and other things, right? Now here we have some transformer. So after this ANN and this LSTM, transformer generation arise. So here transformer are simply some formulas and mathematical calculations through which we are transforming the data into other form, right? So basically here transformers are nothing. Transformer consists of two components which are called the encoder and decoder, right? So using these encoder and decoder, we convert the information into one form, and then using the decoder, we just decode it into the same form, right? So that is what the transformer basically architecture do. And now from the 18 till now, we are having the best of the models. Specifically, I talk about the language. Uh, Here we are working with some pre-trained models, right? Pre-trained models means the models which are already uh, having some data to work with, right? They are already processed uh, using some data, historical data. Okay. Recently, that Chat GPT dropped one feature that anyone can upload. You can say upload their picture, and using those picture, they can generate a you can say artistic picture, right? So that is a one example of how the pre-trained model work. Same way, all of this Chat GPT, Siri, and other AI assistant is currently working, right? So these are the basic concepts how these models are working, right? So every model is either having some uh, pre-trained data or they are linked with some framework. Okay. Now then we having some techniques that you need to understand, like what is tokenization, part of a speech, NER, syntactic parsing, semantic analysis. All of these we are going to have an example to understand better, right? There we will understand all of this in a deep. And then from words to vector, simply we are converting the words to the vector, right? Just like I have defined that every word you are converting it to the vector. Vector means a kind of an entity which is having a magnitude as well as a value as well, or sorry, a direction as well, right? So that you can uh, visualize those onto a 2D plane. Now the reason behind this is that using this concept, we try to figure out the similarity between the words. Just a second, guys. I'll be back in a moment. Okay. So that's what word to vector is. Now here, these word to vector is you can say mm, perform a very significant role while working with the languages. Basically, using these vectors, we are trying to figure out the similarity between the words. Okay. One method here is called cosine distance. So cosine distance is quite famous in working with the words and when you're trying to figure out the similarity between the words. Now, so here enhancing the text analysis. So these are the application I already told about what sentiment analysis, text summarization, spam detection, right? See, previously what we do, uh, spams are filtered at the end, but now spams are filtered while you can say before delivering to the source, right? Oh, sorry, before delivering to the destination, not the source. Means as soon as it originates, it or the algorithm check whether there are any words which are defined in the spam database. If there is word that are defined in that, it just simply drop them. Okay, which enhance the traffic as well in your uh, traffic means network traffic, right? Because it reduces the noise in there. So that is what spam detection is all about in the NLP part. Now, so here some you can say applications like chatbot, machine translation, speech recognition. Speech recognition we have seen a lot of now, like IoT appliances are there. Okay, that is voice enabled appliances are there. You can instruct them through your voice. Then predictive text analysis is there and autocorrect feature, like you have seen in the Google or in other browsers, right? Search engines, they can already automatically autocorrect your thing. Like WhatsApp is also there, right? They, if you are writing something, it automatically corrects your spelling. So that is what autocorrection and predictive text is all about. And finally, we have some uh, you can say future of this NLP part. So here we have some pervasive impact, diverse sector from healthcare to finance, like fraud detection is there, right? One of the major application of NLP is a kind of a fraud detection. You can understand. Uh, Education is there, innovation and driving innovations, right? Then key challenges, obviously, every technology has some challenges associated with them. So there are some challenges associated with the NLP as well. So the one of the most important challenge here is bias. That anytime if you are generating any kind of application, you that depends on the NLP, you must make sure that it is not biased, right? Means it is not generating your result on some you can say assumptions or some regulations, rules, okay, policies, and model explainability are crucial for ethical and trustworthy AI development. Uh, Explainability means whatever task you are giving to that model, right? It generates a clear outcome for that. Let's say, for example, if I ask to the GPT that give me some let's say give me some actual cases of NLP implementation, right? And if it is giving me examples from the core technical part, it's not easy for me to understand, right? If I'm coming from a non-tech background, or if I don't have an understanding about that NLP section, right? So that is what the challenges everyone have. Then we have some trends like multi-modal NLP. Multi-modal NLP means where you can combine text, image, and audio. Like right now, there are a lot of platforms which can generate entire video just by having a prompt. Okay, you simply need to give a prompt and they can create music, they can create image, they can create entire video for you, right? So that is what we call as a multi-modal NLP part. And then we have some economic outlook of it, then conclusion, right? So this is what basically a kind of a introduction, or you can say a brief understanding about the NLP part. Now, if anyone have any question or doubt from this, you can go ahead. Guys, any question or doubt?
No, I'm good.
Okay. Now we will see uh, how we are going to perform these in the real time, right? So there are some terms associated like tokenization, POS, stopwords, chunking, chinking, and everything, right? So there are a lot of terms associated with while working with NLP. Okay, so one by one, we will see all of them in the real-time scenario and uh, how we perform them, how we apply them on a text, right? So I have one. Let me share the another screen. Where is okay? See this. So as I said, that we have multiple methods to work on text. So we are starting by understanding the library first of all. So the library is called NLTK, and NLTK stands for Natural Language Toolkit, right? In this NLTK, every method is already defined to work with, you can say, work with natural language. Okay. So first you need to download it. And then there is one module that you need to download, which is called Punk, this PUNKT, right? So it's a module in which entire methods and everything is defined. Okay, you need to download it. Once you download it, entire functions that are available in your NLTK will work. So first of all, we are starting by tokenizing. Now, what is token? First of all, understand. Token means the smallest part of entire sentence. Okay, the smallest part of entire sentence. Whenever there is a sentence we provide to the machine, right? What first step is that it break down the entire sentence into smallest possible words, and those words we call it we called as token. Getting my point? Guys, token is clear or not? Yes, no? Tokenization is clear?
Yes, very clear.
Okay. Now see, so what I'm doing here, first of all, from the library, I'm importing the module which is called tokenize. Because from in this tokenize, we have the methods called send tokenize and word tokenize. Sent tokenize means breaking down the entire corpus. Corpus means the collection of the sentences, right? Entire corpus. First, it break down into sentences, and then those sentences we break down into words, which we call as a word tokenize. So here I have taken a sample string. So first I'm applying the sent tokenize on it. What it is doing, it is converting entire corpus into my sentences, into individual sentences, you can say. Okay. Once it do, then you need to perform the word tokenize. That is converting your sentences into the words that we call as word tokenize, right? Right. So you can see here that all of the sentences now appearing with individual words here, like Learn is a word rapidly because his. So what it is doing, it is breaking down the sentences into words. Clear? Yes, no? Have we done clear till this? Yes, no? Are you guys clear?
All good, all good.
Okay. Okay. Now, once we have performed the tokenization, then coming to the stopwords. So what are the stopword? Let me share my entire screen. I need whiteboard as well. Um, share entire screen. Right. Understand what are stopwords. Let me write down a sentence here. There is a uh, glass of water on the table, right? As a human being, we can easily understand it. But when you are working with machine, right, and providing everything as an input makes a lot of consequence, right? It basically, you can say, escalate the working of the machine. It takes more resources to generate the output as well as to process the information as well, right? So what we do, we basically try to filter out some, you can say, some irrelevant data, means words, and these are nothing. This is these words we are called as uh, stop words. So in NLTK, for every language, stop words are defined. Okay. Yes, no.
Sorry, what was the question?
No, I'm asking stop words are clear or not?
Oh, it's clear. Things like and is a stop word.
Correct. And is a stop word. A is again a stop word. Is the, right? Right. So these are few. These are some example of stop words. Okay. Everyone. Yes. No.
Yes.
Right. Now, after filtering them out, right? What we have to do once we have filtered it. So as I said, doing here, so I need to download the stop words, and I am specifically working with English language. So I require only those words, okay, that are defined in the English language. Correct? Now see. So here I have used a simple quote here. We know that first of all we have to do the tokenize, that is we have to convert them into a token, and then applying the stop word filtering on it. So once we apply the filtering on it, so there are two methods. Either you go for loop or you can use the list comprehension method. Both are same. Either you can execute cell 12 or cell 13. Both will give you the same answer, right? So you will get some words like this: sir, protest, marry, men. These are the filtered list, the filtered words from the text that we have provided. Correct? Is it clear? This part? Stop words, clear or not?
Clear.
Okay. Now, okay. Now, before understanding this stemming, right? Let's have an example. What is the purpose of this stemming? Uh, okay. Okay, let me write few words here. Helped, helper, helping. What is the common thing about this word, all these three words?
Help. The
They
word
all
help.
come from.
Correct. The word help, right? This. So what is stemming? Stemming is nothing, reducing your word to its base form, right? Like, for example, if I say, okay, if I say bidextrous, what it mean? What do you mean by bidextrous?
No idea.
Bidextrous. Understand. First of all, this we need to understand dexterous. Bi we know two. What is dexterous? Dexterous mean hands. Hands mean those who can work with both hands. Like, if let's suppose if a person is there who can write with both the hands, we call it as a bidextrous, right? So if in you can say, in order to understand the meaning of it, first of all you have to reach to its base form. Understand, we are not checking the meaning of it, no, we are reaching to the base form only, which we call as a stemming. So here, first of all, if let's suppose if you have given this word as an input, it reaches to dexter. Dexterous. Right. Then it find what is dex, and then so on. So that is how the stemming work. Clear? Yes or no?
So this is still schematization, right? Stemming.
Correct. This is what stemming. Right? Now, this is what stemming is. Coming to another form. Uh, so here, how to understand or how to work with the stemmer. We have used here a method which is called Porter stemmer, right? Just like this, we have other stemmer as well. Okay, those having different type of output. Correct. Now, here we are defining one object for it, because before applying the function, you have to create one object. Okay, so here we are defining an object. Then we have this string converted to token. Then on these tokens, you are going to apply the stemmer. So these are the stemmed words means the base words. Like let's say, for example, if you see now discovery and discovered, discoveries, discovering, all of these are converted to discovery, discover, like this, right? Till this done? Yes, no? Till this, everyone done? Clear? Any question or doubt you have?
Clear.
Clear? Anyone else? Okay. Now coming to the next step while working on a text, which is called POS tagging. So what is POS? POS is basically stands for part of speech tagging, right? We know that in English grammar, every word associates with a speech, right? that is grammar of speech. Correct? Now, how to work on it? So first of all, as I already said, that you need to convert the entire text into the words, that is into the token. Okay. So here we have converted into our text. Now I am downloading here, you can say, not a framework actually, but kind of a model, you can say, right? Which is called as averaged perceptron tagger. So in this tagger, the things are already defined. Things mean the words or the part of a speech are already defined. Okay. Parts of a speech are already defined. Now, once we have downloaded it, then simply you need to download one tag set, because obviously once you have applied the tagger, you need to understand what are the tags we have. So here we are downloading the tag set from the same library, that is NLTK, and you can check these are the tag sets. Like if let's say if any word tagged with double C, it means it's a conjunction. Then if it is tagged with CD, it's a numeral. DT stands for delimiter, right? Just like this, there are multiple tags we have, like IN stands for preposition, adjective, right? Proper noun, noun, proper noun, and every tag is there. That is, every part of speech is there. Getting my point? Yes, no, guys, clear?
Okay.
No. So here I have used one simple example here. Okay, and applied the tokenization on it, then performing the PUS tagging on it. So here you can see T was defined as noun, was, brilling, and the, so every word is tagged with a proper part of speech. Correct? You can visualize the same result through a tree. I think I haven't created it. Lematizer, no, I haven't created it. You can visualize the same thing using a tree as well. It means a tree format, right? So you will get some output like this, let's suppose. Or and the next one where if I have, yeah, this tree dot draw, right? So how it will appear, I'll let's suppose for example, if you have a string and then you have converted into a tokens, and one after that you have applied, let's suppose, POS tagging. So what it do, your entire string is there, and then every word is shown in a kind of a uh, tree format, correct? This is what we basically call as a visualizing the text, right? Now, the next step after the tagging is called lematizer. Now we are understanding about the lematizer. Before understanding lematizer, you have to understand about the lemma. What is lemma? Lemma stands for the kind of a base, basic meaning, that is understanding of your word. Okay. Understanding of the meaning, or you can say meaning of the words, correct? That will what is called as a lematizer. So how to work with the lematizer? Again, from the NLTK, you are going to download the method through which you are going to perform the lematizer. Now on this lematizer, or using this lematizer, you are going to check some you can say starting words. Like for example, I have taken here scarves. Scarves is not actual word. The actual word is scarf, right? So it is just reducing that into the actual word. Okay. So here the same thing I have applied. Let's suppose for example, I have a string converted to token, then that all those tokens are now converted to the uh, into its lemma form. Okay. Like worst. See, there is a difference between applying the lematizer and applying the lematizer with a part of speech. If you use the what we call as parameter, the part of speech as a parameter inside the lematizer method, where which I am doing here, it generates a different output. Like let's say for example, if I'm using the lematizer for the worst, it is only giving me that base word for it. But if I need to identify what is the meaning of the word, then I need to define the POS tagging of it. So POS tagging, see, if I'm defining worst, so the POS tag I'm using is adjective. So it means it is a the meaning of the worst is bad, correct? Have we done?
All good, all good.
Okay. Now, coming to the chunking, right? So what is this chunking is all about? Understand? Chunking, it doesn't mean that we are referring to any chunk from your text. No. Chunking means identifying whether your text having any phrases or not, consist of any phrases or not. That we call as about chunking. So it's very simple how to work with chunking. We have, let's suppose, for example, I have taken a example here. A string is we have. First, I have converted into the words, then PUS tagging. Then I am defining the grammar. Okay, this is one of the most important part of understanding or working with the NLP section. What is grammar? So here I am defining how my sentence or how my phrase look like, right? That is, it starts from a proper noun. It can have a delimiter. It can have a what this JJ stands for, adjective, I think, right? Let's check what this JJ, no, not adjective. Mm, adjective, right? Right. Yeah, let's go. Yeah, here it can have any. Sorry, after the delimiter, it can have an adjective and any number of noun. So this is the rule that we are defining to identify the phrase in my sentence. Getting this? Yes, no? Anyone? Any question, doubt? Guys, any question, doubt you have?
I have no question.
Yeah. Now, this is what or how we work with NLP, right? Now, coming to some basic discussion, right? Apart from this NLP thing and all. Okay, tell me how many of you are already having some understanding about this entire things like machine learning, NLP, like data analysis, AI, Python. Is anyone there? Or at any instance you thought about giving a try to learn about it?
I learned a little before.
Mhm. Okay, may I know anyone there who is already uh, working in this domain? Is anyone there?
I got certified in the AI 900 last year.
Good, good. So what you have studied there?
I studied almost all of these, but that was like preparing for the exams. I haven't really gotten into the hands-on, but I did some hands-on before.
Okay, okay. So that means you are comfortable with machine learning and all, right?
Yes, I am.
Okay. Any real-time project you have done?
Actually, when we're doing the hands-on with some friends, we did some NLTK hands-on, like we did sentiment analysis
Mhm.
on some Twitter customers.
Uh-huh.
We did something like that, and we did a chatbot, translation chatbot.
Uh-huh.
These are some of the few ones that I can remember. It's been more than half a year since I did it, so
Okay. Okay.
I haven't been practicing. I could say that.
Uh-huh. Uh-huh. Good, 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 good. Anything from your side, Okhil?
It's on the in the floor. We are just four of us, and it will be you and Mr. Kalkey. So just two of us will say are the students right now.
Mm-hmm. Okay, so anything you want to understand, you want to discuss apart from this, or anything related to kind of different met you can say concepts in AI, not just NLP. If you have any doubt, if you have any concern, any kind of discussion you want to do, you can go ahead with that.
Okay, I would like to ask, since we are doing the NLP, can we try sentiment analysis on Python?
Hmm.
I mean, like on the Jupyter Notebook, can we try one example of how to carry out sentiment analysis, like a hands-on?
Okay, you want sentiment analysis, right?
Yes, because we are doing LRTK, right?
Right, correct.
Uh,
Okay, okay. So let's plan a session
Okay.
on this, right? So in the next session, I'll try to give you an idea that how to work with sentiment analysis.
Yes.
Okay.
Okay. That would be great. That would be great.
Yeah.
Because like this course is great, but I think some of the people without a foundation is a little difficult. Like in Python,
Uh-huh.
they,
So see,
you,
that is why we are providing the entire course,
yes.
right?
Okay.
There we are starting with the basic of Python. We
Okay.
cover Python, then we cover the statistics, then
Yes.
we do the machine learning thing, right?
Yeah.
So we are starting with the scratch, and then we are moving toward the main part.
Main part. Okay. Okay.
Yeah.
That's nice. It's nice. It's good to follow up.
Right,
And
right.
uh, with after passing, for example, I have passed the AI 900.
Uh,
Where do I stand? I passed it last December. I started
uh,
really for it, and I passed the exam. But since I'm busy working, I haven't really even built my resume to ask for jobs. Which field
uh,
in the AI domain can I really pursue, in your opinion? Which field is really good for me? Should I go in for a full-time job, or should I go in for an internship?
See,
Since I
the
don't,
thing is, see, the thing is, certifications, obviously, there is a weightage for the certification, but
yes,
now the scenario is changed. Instead of certification and degrees,
yeah,
companies are looking for skills,
skills, yes,
right? If you have worked with varied projects,
okay,
correct, there is more chances to get select.
yeah, that's it. We did some projects when we were working together when I was studying for the course.
Hmm, 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 hmm.
Did some
But see,
projects,
projects, obviously projects are there, but it doesn't mean that you have worked on some dummy project. No, there
yeah,
are lot of dummy projects. Correct.
yeah, I know,
Companies are looking for
real projects.
professionals. Yeah, correct. Real projects, right?
Look at like we all know the breast cancer,
Ah,
diabetes, all of that.
correct, correct,
The
correct, correct, correct.
we all did that, but companies are not looking for that. They want the real
No, no,
projects.
no, no, no. They are not looking for that,
Yeah.
right?
Yes.
So that is, see, that is why our course is defined in that way.
Yeah.
We have real-time projects with case studies, case scenarios, everything.
Yes. 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 All right. So when you have a real-time internship, your internship leads to a job. The internship you guys carry out, like the paid internship, right? Does it
Mhm.
lead to like does it lead to job? Do you have the opportunity like assigning someone for a job, prepare someone for a job, and then maybe you have some networking to guarantee jobs?
Mm, I think this thing the team will give you a better idea about it,
Okay.
right?
Right. You've been very helpful. and I want to get some hands-on experience, some real projects that I can show, and then from there I can really put on my resume. I can be working on some of the internships I did online. Those online internships, you can't count them very much. But the real projects that you do, and then you can say that I did this project, you can put them on the resume. I don't have those projects, so my resume it's been more than half a year. I haven't even worked on it because I don't have the projects. So
you need to look into that.
okay.
You need to find some projects, right? Where you can have some hands-on skills. You get some hands-on skills, right?
Yes.
Then it will definitely increase your chances to get a job.
Yes, I'll do that. I'll work on that. It's just that sometimes the avenues to get the hands-on is not because you can only practice on some of the projects you have on. That's just practicing on them, and some are already done.
Correct.
But they need something that you did on the field. So that scenario, I'm trying to create one that I can work. That's what I was thinking about, going in for an internship in a company. That would be better. I'm thinking about that. Okay. Thanks a lot. Next session will be like next week or after 2 weeks?
No, next week.
Next week. Okay. I attended the first session when we did CNN. So we did CNN, and then the last 2 sections I didn't attend.
Okay.
So, it's just the issue of time. I think my time difference and your time difference will be almost similar. What time is it now in India?
It's if I talk about this session conducts at 7 p.m. IST.
Yeah, your time is 7 p.m. Right now is 7 p.m. there.
Yep. No, it's 9 now.
9. You're 2 hours. I am in China, so I'm 2 hours ahead of you. So,
Okay.
So I'm 11:23 now. While you're 9:23. Sometimes the time doesn't really favor me. Most of the times, yeah. All right. You've been very helpful, and thanks a lot. All right. Okay, I think.
Right. So we will meet on next week.
Next week. Okay.
Yeah.
Thank you, and have a wonderful weekend.
Same here.
Bye.